Welcome back, everybody. Today we're moving into a new section, but we're still talking about organizing data. We're just going to organize data in a new way into what we call a frequency distribution, and then we'll talk about a graphical way in a histogram. All data starts out as raw data, as exampled by the numbers I've shown you on the screen. But raw data by itself makes it really hard to draw some conclusions. So far, we've explored two ways to sort your data. The first is the stem and leaf plot. And the second is your box plot. Both are good. Both have their pluses and minuses. But again, frequency distribution allows you to put it into a table format. Histogram is just another way to graph. So we'll just explore those two ways today. All right, so we're going to use this data, and we're going to set up our frequency distribution in the following way. When you start out, I really like setting up your frequency distribution in this fashion. We have our class limits. Tally and frequency. The tally column is more of, kind of where you're showing your work. Not necessarily mandatory, but when you're starting out, it's always a good place to, good column to have. Now, for the first one, I'm going to give you your class limits. Later on in this video, we'll talk about how to get your own class limits. All right, so I'm going to say 1 through 3, 4 through 6, 7 through 9, 10 through 12, 13 through 15, and let's get the last one at 16 through 18. Remember, your class limits need to be able to encompass all of your data. Again, the tally section is where you're going to show your work, and the frequency basically is just asking you how many of these above numbers are between 1 and 3. And the frequency is really what we're looking for. So here's what I'm going to ask you to do. I'm going to ask you to pause the video. All right. I'm going to ask you to take a look through your data. And, I'm basically going to highlight any number I see between numbers 1 and 3. Inclusive. So now I've been doing this a while, so I don't necessarily use my tally column the way I probably should. But so I'll count them up now. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So probably as I was counting them and crossing them off, if I was using my tally column, I'd probably 5, 6, 7, 8, 9, 10. And in the frequency part, I would put 10. So at this point, you're going to pause the video. I'll leave the data up on the screen for you. And I want you to give me the frequencies of each of your classes. All right, hopefully you paused the video and were able to tally up your frequencies. Now, the way to check your work is to count the number of raw values you have. I counted out to equal 50, and you add up these numbers. And we see that this adds up to 50 as well. So it looks like we didn't miss any, all right? So the benefit here is that the data gets organized into classes, right? So it's better organized than the mess we had up before. The downside is we lose the actual data values. So for example, we know that there are 10 numbers between 1 and 3, inclusive. We just don't know what those numbers are. We don't know if it's 10 ones or if it's 3 1s, 3 2s, 4 3s, or anything like that. All right. But we're still able to work this way, and we could still draw some conclusions. All right. So there are a couple of different kinds of frequency distributions. This is called a grouped frequency distribution. There's another kind called a categorical frequency distribution, which we will explore in just a minute. All right. So let's get into our categorical frequency distribution. All right, so one of the better ways that I have for explaining a categorical frequency distribution is just to take a look at an example. So let's take a look at this one. 25 Army inductees were given a blood test to determine their blood type. The data is as follows. All right, and the question is, create a frequency distribution. All right, now the reason this is called categorical is because our classes are no longer going to have numbers, right? Our classes aren't 1 through 3, 4 through 6. Anything like that. Our classes are going to be our blood type. All right, I'm going to try to keep that up as long as possible, but I'm going to say class put in my tally column just because I like to have a place to show my work. Frequency and percentage. Now, again, the beauty of the frequency distribution is there is no set number of columns. For example, if this question were asking what percentage of recruits had blood type AB, having percentage right in your chart might be really helpful. Like if they said, what are the percentages of blood types of all the recruits? You could say, you know, very easily to read from your chart to say A is this many percent, B is this many percent, O is this much percent. So sometimes it's really helpful. All right, have as many columns as you need. For example, if you get to a point where you don't want to have a tally column in there, don't have it. But you do need to have columns that will help you the most. So let's start with our classes. I have A, B, O, and AB. All right. So now here's what I'd like you to do. I'd like you to pause the video, and I want to know in the frequency column how many recruits had blood type A, how many recruits had blood type B, how many recruits had blood type O. So I want that. And I also want the percentage. All right. So I'll see you on the back end. All right. So if you use the tally column, that's fine. I found that there were 5 that had blood type A, 7, 9, 4. All right, I'm going to scroll up so I have a little bit of place to room to move. So the total, 25, and I double checked by counting the number of data values I had here. I said 1, 2, 3, 4, 5. I put 5 in a column across, and I have 1, 2, 3, 4, 5 columns down. Means 25 data values. So I used that, and I found that 20% of my recruits had blood type A, 28% had blood type B, 36 had blood type O, and 16% had blood type AB. And then I always double check to make sure that this adds up to 100, because all percentages are supposed to add up to 100. All right, so one of the things that you could say about this is that more people recruited in this class had blood type O than any other type, right? Because you had 9 in your frequency and 36% of your total had blood type O, more than any other blood type. All right. So now I want to talk more about the grouped frequency distribution. That was just like the one we did in the beginning, but I gave you the classes. Now, I want to talk a little bit about some of the rules of the road regarding making the classes, because you won't always be given them. Sometimes they'll say, right in the directions, use 7 classes, use 5 classes, that kind of a thing. And that's really helpful, but sometimes it won't. So I'm going to say rules for frequency distribution. All right, and the first rule is there should be between 5 and 20 classes. I think for purposes of school, not going to see a whole lot of 20 classes, but you know, when you get some very large data sets, the more classes you have, sometimes the more conclusions you can make. Second rule is that your class width should be an odd number. Odd number. All right, and the reason this is because if you remember back to when we calculated the mean, we actually did the mean of grouped data. So the data was already in a frequency distribution. And one of the things we used was the class midpoint. So if the class width is an odd number, then your class midpoint has the same place value as your data. All right, and that's really helpful. All right. The third thing, and this is something that's overlooked by a lot, so I do like that it is included in these rules, is that the classes should be mutually exclusive. All right, and what I mean by this is, I'm going to scroll up a little bit, try to keep this on the screen, is that very often I see people make, right, and I'll call this frequency, classes like this, where they make like 10 to 20, and then 20 to 30, and then 30 to 40, right? And you say, well, these are, you know, there's no overlap here in these classes. My question to you would be, where do you put a data value of 20? Where do you put a data value of 30? All right. So I think the better bet, and this is what they're driving at with this rule, is that it should be something like this. I'll use F for frequency. Should be like 10 to 20, 21 to 31, 32 to 42, and so on and so forth. So it's pretty clear where 20 goes, it's pretty clear where 30 goes, it's pretty clear where 40 goes, right? And even the number like 31, it's very clear that that goes into the second class, and 20 goes into the first class. So it needs to be clear where these data values go. All right, rule number 4. The classes must be continuous. All right, and what we mean by this is that, so let's actually I'll scroll up, I'll use this one right here. All right, let's say there's 4 here, 0 here, and 10 here, and so on and so forth, all right? Even though there are no values that go between 21 and 31, we still need to keep that class there. We still need to show 0 data values, all right? So don't show it as a blank, literally put a 0 in there, all right? So don't skip that class just because there's 0 in it. All right? So number 5 is that the classes must be exhaustive. All right, and what they mean by this is that all the data values need to be used. So you don't want to just start writing numbers down, because if, let's scroll back up here, let's say this was our last class and we had a data value of 50, what class would it go in? All right, and you don't want to just keep making up stuff. All right, so you can't. All right, and the last rule is that the classes must be of equal width. Meaning that, let's say we come into the situation I just described, and we have these classes. You can't just erase the 42 and put a 52, so we can take this data value and get it in there. All right? So that would be wrong. All right. So what we're going to do is we're going to take a look at a quick example, and then we'll make our classes together. All right, so here's the next example. The following data represents the record high temperatures for each of the 50 states. Construct a grouped frequency distribution. Now notice I haven't told you how many classes to use, and I haven't told you what the classes are. What I'd like to do is I'd like to go through using this as an example and see what we can figure out together. That way, if you're confronted with a problem that doesn't necessarily give you that information, you're able to construct your distribution anyway. All right, so first thing we need to do is determine the classes. So I'm going to scroll up. Don't worry, the data will be here. I'm going to scroll up a little bit. So step 1, determine the classes. So I'm going to do the highest minus the lowest. So I look at my data. I found my highest to be 134, and I found my lowest to be 100. So I do 134 minus 100. That equals 34. And now we need to select our desired number. I'm going to use a different color just to make contrast. Select a desired number of classes. All right, now here it's a little bit by feel. It's a little bit of an art more than a process. You want a good amount of classes that that you're putting multiple data points into each class, but you don't want it to be so fine that you have to have 20 classes. 20 classes can be quite unwieldy. So you select the number. So let's say I pick 7 classes. Usually between 7 and 11 is a pretty good amount. The more data you have, the more classes you may need. So let's see, if I take 34 and I divide it by 7, I get 4.9. You're welcome to check my math. But I'm going to round that to 5 anyway. Now, I really, anytime I get a decimal in this, I really want to round up. The reason I want to round up is because of that rule where the classes must be exhaustive. You would hate to write out all your 7 classes, put all this data in your frequency distribution, and then realize that 134, it falls outside of that last class. So even if it was 4.1 or 4.2, I probably would round up to 5. All right. So now we're going to make our classes. All right. So I'm going to go back to blue just because it shows up a little bit better. I'm going to say, all right, class limits. All right, and we're just dealing with the class limits right now. So I have 100 is our lowest value, so that's where my classes are going to start. And my next class starts 5 units later, so my next class will start at 105, then 110, 115, and so on and so forth. Now, where does the class end, you say? Well, the unit before 105 is 104, right? 109, 114, and if this is going to be 120, this will be 119. And what we're going to notice here is that if you basically counted on your fingers, let's say you said 100, 101, 102, 103, 104, that's 5 units. All right? Same with 105, 106, 107, 108, 109. That's 5 more units. This is just kind of an easy way to make them up. All right, so let's fill in the rest of our classes. And we know that our top value is 134. So our last class, right, will include that data value. Just going to put some lines so we can differentiate. There we go. And I want tally and frequency. All right. So at this point, why don't you pause the video and do your tally and frequency. All right, so hopefully you tallied them up. I got 2, 8, 18, 13. Uh-oh, hang on. 7, 1, and 1. So that's the frequency. You can also add a column called cumulative frequency, which basically will... So like if I call this cumulative frequency, right? I have 2, so the cumulative so far is 2. I'm going to add 8 more, so I would put 10 here. I'm going to add 18 more, so it's 28. I'm going to add 13 more, so it's 41. Yeah, that's a terrible one. Let's just make that a little bit better. And I'm going to add 7 more for 48. 49, and 50. And again, not a requirement to have cumulative frequency. I'm just showing you that there are a variety of different columns you potentially could have based on the question you're being asked. They could say, how many states have a high temperature below 114? In that case, cumulative frequency would help because you could say right here, that would be 28. All right. So by now we are experts at making frequency distributions, all right? And we've dealt with class limits, all right? So I'm going to make another table real quick. Class limits. All right. And I'm going to say I got 3 classes. There we go. Sometimes we don't want one unit separating our classes, but we do want our classes to be distinct. All right. Now, in relation to this data is all temperatures, correct? And all the temperatures end in the ones place. So we can actually move these closer together by making class boundaries. Now, class boundaries are going to go one digit beyond your data. All right. So, for example, our data for our temperatures ends at the ones digit. So we're going to go to the tenths digit. And we're going to do what we call add and subtract. So, for example, for 100, I'm going to subtract 0.5. So I get 99.5. That way, if there was a class before it, and you'll see what happens here. And I'm going to add 0.5 to 104 to get 104.5. Then I'm going to subtract 0.5 from 105 to get 104.5. I'm going to add 0.5 to 109 to get 109.5. I'm going to do the same thing with 110. I'm going to subtract 0.5, so I get 109.5. Add 0.5 to 114, 114.5. And we can do this for every class in our set, right? We want to slide these just a little bit closer together. That way, if we were to graph it on what we call a histogram, right, there would be no space in between the classes. Now, the good thing about our class boundaries is that because we go one digit beyond our data, there is no data point that will fall on the boundary. So, for example, there is no data point 104.5. There is no data point 109.5, which means that the worry about where to put 109.5 does not apply. All right, and we will be discussing more about histograms in part 2. All right, so part 1 is over. All right, there is more practice to be had, but you should definitely watch part 2 next, because what we do is we take from our frequency distribution using class limits, class boundaries, and we apply it to a new representation called a histogram, which basically will take our data and we'll graph it. All right, so thanks for listening, and I'll see you soon.